Hello and welcome to CCSA R80.40 training. The agenda of this section is to understand a firewall and firewall technologies, packet filtering, stateful inspection, application layer firewall, legacy firewalls or traditional firewalls versus next generation firewalls. Let's first understand what is a firewall. A firewall is a security gateway device that controls traffic flow between network segments, right? Firewalls can be a hardware, software, or combination of both which are configured to meet an organization security needs. The most effective way to secure the internet link is to put a firewall system between the local network, the LAN, and the internet. And most firewalls are default TNI device, right? So I hope you all understand routing concept, routing principles, right? And like different steps involved in IP routing. And let me explain a very quick discussion about routing principles first, and then I'm going to explain about security gateway. So in IP routing, there are three main steps. In IP routing. Step number one, finding out longest matching route and exit interface. Step number two, switching, that is moving packets between the interfaces. And step number three, switching, Step number three is encapsulation, that is building layer 2 header. All right, so let's first understand like all these three steps involved in IP routing. So a router here, host machine on the LAN segment, and F0/0, the LAN interface IP is 10.0.0.1, and this host machine IP is 10.0.0.2 with the default mask 255.0.0, and gateway here is 10.0.0.1. Let us assume that this host machine, client machine on the LAN segment wants to communicate with another host device with the IP 172.16.1.1, right? So since the destination IP address is not from the same network segment, so gateway will come into picture, and this ICMP packet like will get encapsulated inside Ethernet header. But for that, like this source machine, the client machine needs to know the MAC address of the gateway 10.0.0.1, right? So first, this client machine will check its local ARP cache table, and if it finds MAC address of the gateway in the local ARP cache table, then there is no need of like generating ARP broadcast message. But if there is no MAC address mapped with the gateway IP, then ARP messages are like broadcasted with the client machine to obtain the MAC address of the gateway. And once client machine obtains MAC address of the gateway, then the packet is encapsulated inside Ethernet header, right? So here like layer 2 header, IP, ICMP, and for error checking, FCS, frame check sequence, right? And layer 2 header here means like source MAC address, destination MAC, and ether type field. Source like sender, destination MAC means gateway MAC address, and the type field, ether type field. Packet here. So router receives Ethernet frame, and router will first look at the layer 2 header, and if it finds its own MAC address as the destination MAC address, and there is no like error in it, then packet is taken out of data frame. So router extracts packet from the data frame, like IP header and then ICMP here, right? IP header is like of 20 bytes, and IP header means like destination IP address. There will be source IP address, time to live, for QS like type of service, DF bit, do not fragment bit, IP option field, length, checksum, right? Router will be interested in like only destination IP and TTL value, time to live, for the routing purpose, right? Because routing means destination base. Even the source IP address will not be checked. Source IP address by default is never taken into account at the time of making routing decision by default, right? There are different ways to like do source based routing, but by default source IP address is never taken into account. So router will of course see like whether this TTL value is any like non-zero value, and should be non-zero value, and then the destination IP address. Okay, so router will check the routing table, like do I have a route, do I have route for the destination IP, and if router finds a matching route in the local routing table, then router will perform recursion or reverse routing table lookup to find out egress or exit interface, right? So first finding out matching route and then egress or exit interface. The next step here is switching, that is moving packets between the interfaces. So let us assume that the egress interface here is F0/1. Then the packet is moved between the interfaces. Between the interfaces is a packet layer 3, right? No layer 2 frame here. Now the third step, encapsulation. Again, this router encapsulates packet inside layer 2 header, right? If it's Ethernet media, then again layer 2 header is added to it and then set across. That's it. That's all about routing principles. It means in IP routing, there are 3 steps: finding out longest matching route and exit interface, switching, encapsulation, right? And router is default permit device. It means by default, traffic is not controlled. If there is matching route in the local routing table, then packet is routed. And even router will not inspect data up to upper layer, because the destination IP address, of course, here like the destination IP address will be 172.16.1.1. It's a data plane traffic that need to pass through the device, not to the device. So router will never look at the upper layer, only layer 3 inspection. And no like a security check here. I mean, like, what about the source IP? Let's say the source IP address here is same as the destination IP address, right? Source IP address is same as the destination IP address. Will router check that? No. Source IP address is not taken into account. In fact, it is never checked. What about this IP option field? What if it has some data in it? Router will perform any check here? No, right? What about firewalls or security devices? Of course, they do perform routing. They do do routing in the same way, like 3 steps: longest routing, matching route, exit interface, switching, encapsulation. But apart from that, apart from doing the routing, even they do a sanity check. If like firewalls find data in IP option field, then it is dropped. Packets are dropped then. Source IP address, what if source and destination IP address, they both are same? Source and destination IP address, they both are same, right? Source IP address, for example, is 10.1.1.1, Destination IP address is again 10.1.1.1. It's not a legal illegal packet, because the source and destination IP, they both cannot be same, right? What if the source IP is any multicast address from the class D? Again, illegal packet. Why? Because source address can never be a multicast address. Multicast address would be always the destination address, not the source address. Source address would always be unicast address from class A, B, and C, right? So most of the firewalls, what they do, of course, they perform routing. Apart from that, even they also perform like layer 3 and even layer 4 checks, right? And packet is routed only if it's a genuine packet, legal packet. As there is no IP spoofing involved, there is no data inside IP option field. Source IP address is also valid. Then only packet is routed, and even to control the traffic, security policy security policy will come into picture, because most of the firewalls are what? Default deny device. Most of the firewall, for example, if we put a checkpoint firewall here or security gateway, internet, LAN side, so yes, it does routing, no question about that, but packet is allowed to pass through either from this inside to outside or outside to inside, right? Let's say it's my inside and here is outside. Packet is allowed to pass through the device only if there is security policy that allows the traffic, right? It means security policy controls the traffic, whether traffic should be allowed or not allowed, decided by what? Security policy. If we do not create security policy and we deploy a firewall inline, I mean in the path of the like communication stream, inline deployment, and we do not create security policy here, then there is implicit deny. Traffic is not allowed to pass through the device, not from inside to outside or outside to inside. Zero security trust model. And why most of the firewall? Because Cisco ASA firewall, adaptive security appliance firewall, when we configure Cisco ASA firewall, then what we do, uh, apart from like assigning IP address to the interfaces, we also set or assign security label, security label, right? Security label. So by default, interface with the name inside is assigned security label 100, and all other interfaces with the security label 0 by default. And by default, traffic from high security level to lower security level is allowed to pass through. It means traffic from inside to outside is allowed by default. And being a stateful firewall, reply packet is by default allowed. So we need not to worry about the reply packet, right? Of course, only TCP and UDP. By default, only TCP and UDP based application. By default, ICMP is not inspected. For that, we need to like run some command. But by default, TCP and UDP applications, they both are inspected, and the reply packets will also be allowed. But the first packet, the request packet, of course, should have been initiated or originated from the like network segment with higher security level, because higher security level means trusted network, right? But in checkpoint firewall, without creating security policy, traffic is neither allowed from inside to outside nor outside to inside, like between two different interfaces, traffic is never allowed, right? Be assured of that. So whenever we talk about like firewall, so we always use the term security gateway device. Security device or security gateway device is a gateway network firewall, but there is security, right? Security in it. So it's different from the router. Router is default permit device. On the other hand, firewall means default deny device. So I hope you understand like the basic difference between a gateway or the routing and a firewall, that is a security gateway. So security gateway means inspecting attributes or parameters of layer 3 and layer 4 header first, and then checking with the security policy whether the traffic should be allowed or not. If allowed, then will it be allowed, not allowed, then will not be allowed. Okay. Controlling network traffic. Managing firewalls and monitoring network traffic is the key role of network security administrator. The firewall or the security gateway with the firewall enabled will deny a permit traffic based on the rules defined in the security policy. So security policy means like grouping of rules, or a security policy consists of security rules, and security rule are always like examined from top to bottom. Because in routing, another important point to note down here is in routing, if a router has, let's say, a total 30 or 35 routes, so all 35 routes are checked, right? And most or longest matching bits or most specific route is preferred, no matter what the placement of route is in the routing table, whether the route is at the bottom or top, no matter where the route is, right? Most specific route, longest matching route, that means host route is always preferred as compared with the network or subnet route. What about the security policy? If there is a firewall here, right, and we have created security policy, and security policy means like consisting of different security rules. So here like the sequence is very important. Sequence is very important because security rules are processed sequentially from top to bottom, and if a match is found, then no further inspection or examination will be done. It means placement of security rule is very important in firewall. Security rule placement, where the rule is at the top or bottom or in between, right? So it's really very important. So the following technologies are used to deny a permit network traffic. So let's understand like the packet filtering, stateful inspection, and application layer firewall. First, packet filtering. Packet filtering is the most basic form of firewall, but packet filtering means like the best example is router ACL, access control list, operates up to layer 3 and layer 4 of OSI model. It means traffic is allowed or denied on the basis of layer 3 address, that is IP address, source and destination IP address, and layer 4 address, that is destination port address, right? Layer 3 and layer 4, network and transport layers of the network architecture. Packet filtering is usually used on Cisco routers using ACLs. This filtering technology is good as a first line of defense because there is no like application aware inspection, no application intelligence, no knowledge of application, because data is not inspected up to layer 7 of OSI model, only layer 3 and layer 4. So even if we allow port 80, means all HTTP based applications will be allowed, because we'll check only the destination port address, port 80, and that is why like sometime it is also known as port and address based firewalls. Port and address based firewalls. Pros and cons: application independence, high performance, of course, is scalability, because uh, data is inspected up to layer 4 of OSI model only, and of course no knowledge of application. Low security, no screening above network layer, and no state or application context information is very important point to understand here. So let's say a router and the interface that connects to internet, I mean like the external interface. Here let's say I have created and associated access list to deny all traffic coming from internet side, originated from internet side. It means only one statement here, like access list, let's say 110, deny IP, source any and destination any. And let us assume gig 0/1 is the interface that connects to internet, and here IP access group 110 inbound, right? It means there is an access control list associated with external interface, and this ACL is to what purpose? To deny any traffic coming from internet site, right? But what if a first packet, request packet, is allowed to pass through? First packet is allowed to pass through this ACL, either like there is no access control list here associated to this gig 0/0 interface, or there is ACL that allows like traffic to pass through, means request packet. So what do you think? Reply packet will be allowed or not? Yes, correct. Reply packet will not be allowed. Why? Because router doesn't maintain connection state table, right? State of the connection is not known to the router. Router of course allows the packet and forgets, right? So that is why what will happen? What about this reply packet? Reply packet will be checked with this ACL, and what's the statement in the ACL? To deny everything, like no matter what the source is, what the destination is. It means router is not in a position to bifurcate request and reply packet. Reply packet is again like treated as if it is a request packet. There is no mechanism, there is no way to differentiate request and reply packets. So you understand now it's very difficult in production network. You cannot deploy like a router with the ACL, in fact, because for each request packet you'll have to write down another ACL for the reply packet. So you understand, like it's very cumbersome, it's not like it's scalable, cannot be used. In fact, from that perspective it's not very scalable, because uh, I mean like writing down different ACL for different a reply packet is literally very difficult task to do. So the problem here is with the ACL is it's a stateless, not stateful, stateless. Connection state table is not maintained, right? It means we need to write down two separate ACLs, one for the request and the for the reply packet. A very big drawback. Stateful inspection. Stateful inspection. Stateful inspection lies a packet source, destination, destination address, source and destination ports, protocol number like ICMP or TCP or UDP, and content. With stateful inspection, the state of the connection is monitored and state tables are created to compile the information. State table, the important point here is state table holds useful information in regard to monitoring performance through a security gateway. So stateful inspection means what? Connection state table is maintained. A session table is maintained by the firewalls, right? Connection state table. So if it's a firewall here, and if request packet is allowed to pass through the firewall, request packet, from the security policy, of course. If there is a security policy that allows request packet to pass through the device, so for reply packet, really we don't need to write down in the security policy. Reply packet will be allowed automatically, right? So whenever we write down the security policy for stateful firewalls, we only write down security policy to allow request packet, right? We never bother about reply packet because reply packet is by default allowed, because one of the feature of this SPI or stateful packet inspection is what, like it does maintain a connection state table. So for TCP based communication, connection state table means what, like source IP, source port, destination IP, destination port. For TCP, even the flag, initial sequence number maintained in the connection state table. So if the very first packet, like here from the LAN side, it is allowed, let's say for TCP based communication, it means the first one is with SYN flag. So the reply packet will have SYN-ACK flag. So for that, we don't need to create security policy. Even security policy will not be checked. If it finds a matching entry in the connection state table, and it's very intelligent device, so it understand, like if there is a SYN-ACK packet, then there should be a connection entry in the connection state table with the SYN flag. And if there is like already entry in the connection state table with the SYN flag, then this SYN-ACK reply packet, the second packet, is by default allowed. Really, we don't need to create any security policy. Even for UDP based application, like source destination IP, source destination ports are maintained here in the connection state table. So stateful inspection means, like, first maintaining connection state table. Connection state is known to the firewall now. It's not like the connection stateless behavior. I mean, like routing the traffic and then just forgetting everything. No, it's if it allows the traffic, then immediately step down to first take down the information from the packet, like the source IP, destination, source port, destination port, protocol number, and a flag in case of TCP based application, sequence number, and it's written down here in the session state table. Reply packet is first checked here. So it's very important behavior, and this SPI concept, like it was patented by Checkpoint. In fact, SPI is stateful packet inspection. So good security here, full application layer, high performance, extensibility, and transparency. Difference between stateful inspection versus packet filtering. Okay. So stateful inspection differs from packet filtering in that it deeply examines a packet not only in its header but also the content of the packet. Because stateful packet inspection, so of course firewall understanding, the context of the communication, in what context the communication is taking place, right? So stateful inspection means not inspecting only header but also the contents of the packet up through the application layer to determine more about the packet than just information about its source and destination. In addition, packet filtering requires creating two rules, correct? One for the request and another for what? Reply packet, correct? In a stateful inspection, only one rule is required, only for the request packet, not for the reply packet. So it's very easy as compared to packet-based filtering. And what about the application layer firewall then? Application layer firewall. Application layer firewalls operate at the application layer of TCP/IP protocol. I'm sorry. Firewall operates at the application layer of the TCP/IP protocol stack to detect and prevent attacks against a specific application and services. Granular level of filtering, of course. Filtering at the application layer offers the best level of security, however it is slower and so require more processing power when inspecting each packet, often referred as next generation firewalls. Next generation firewall, because it includes traditional functions of packet filtering and stateful inspection both. So and the difference here, like legacy or traditional firewalls versus next generation firewall. So legacy or traditional firewalls typically provides a stateful inspection of incoming and outgoing network traffic that entering or exiting point inside the network. It allows or blocks traffic based on state, port, and protocol, and filters traffic based on administrator defined rules. It doesn't support application level awareness, traditional firewalls. It has features like packet filtering, network address translation, VPN termination. So yes, like even on legacy or traditional firewalls, we can terminate VPNs like site-to-site, IPsec, mobile, RSSL can be terminated. Complete NAT functionality is there, of course. Uh, Even like filtering on the basis of state, port, and protocol, but no application aware inspection, no application intelligence in legacy or traditional firewalls. And that is why in legacy or traditional firewalls, evasive tactics can be used to bypass the firewall. Evasive tactics. What does it mean, like evasive tactics? So let me explain. So it's a traditional or legacy firewall, right here. And if let's say there is a security policy to allow web traffic. So how web traffic is identified by the firewall? Just looking at the destination port address. If the destination port is 80, that means what? Web traffic, right? But nowadays, there are different tactics, evasive tactics, that can be used to tunnel one protocol inside another protocol. That is known as tunneling inside another protocol, or port hopping, right? Even there are some advanced techniques like tunneling inside SSH or SSL. So very easily traditional or legacy firewalls can be bypassed, because if firewall is not going to perform deep inspection inside the application data, I mean like if only this TCP or layer 4 header is checked to identify the application, so definitely evasive tactics can be used to bypass the firewall, like the port hopping, protocol hopping, or tunneling inside another protocol, because there are different ways to bypass the firewall. So it's very easy. It's very easy to bypass the firewall. And even like as there is no threat prevention in legacy or traditional firewall, like any spyware, vulnerability protection, or antivirus, or some other like denial of service attacks, or preventing zero-day attack, sandboxing technology. As such, there is no threat prevention at all in legacy or traditional firewalls, right? So what about the next generation firewalls like Palo Alto or Checkpoint? A next generation firewall is a network security device which not only typically provides stateful inspection of network traffic that entering or exiting point inside network based on a state, port, and protocol, but also include far more additional features than traditional firewall. The additional features are what? The additional features here, like application awareness and control, IPS, deep packet inspection, cloud delivered threat intelligence, HTTPS inspection, anti-spam, anti-bot, DLP. So let me like explain all the new additional features here in next generation firewalls. Application awareness and control. So next generation firewalls means like in order to identify applications, not only destination ports are checked, even this application data, upper layer inspection, like deep inspection inside this application data is done to identify the application, because next generation firewalls, they already have application database. I mean like the application signature database. It means firewalls, they know about commonly used applications, 3,000 applications, 5,000 applications, 6,000 applications, right? Of course, it varies from vendor to vendor. So they already have a list of like well-known, commonly used applications, application signature database, right? So what they do, in fact, in order to identify application, first, of course, they will look at the layer 3 header, layer 4 header, and then deep inspection inside this application data to identify the application. So now really here, like, it's very difficult to bypass the next generation firewall by using any evasive tactics. For example, like tunneling inside another protocol. So most next generation firewall, they have protocol decoders. So protocol decoders are used to identify that whether one protocol is being tunneled inside another or not, because tunneling in is allowed, right? Tunneling, you understand, like tunneling means like, in very simple word, if I explain, for example, let's say here, like there is a packet or data packet is here, and then TCP and then IP here. So even this packet can be further encapsulated inside another protocol. For example, you must be aware with this GRE, a Cisco implementation, generic routing encapsulation. So the packet can be further encapsulated inside GRE and new IP header is added to it, right? Because in data, it's not like data in this portion here, even there can be another complete packet inside it. I mean, like IP, TCP, and data. Of course, like there are certain, like, in fact, things that we need to take into consideration, like the M2 and MSS and all that. But let's not talk about like M2, MSS, and other stuff here at this point of time. It means very easily one protocol can be tunneled inside another protocol. That is allowed, that is acceptable, no problem whatsoever. So next generation firewalls, they have protocol decoders to identify that whether one protocol is being encapsulated inside another or not. And even they have complete understanding about the application. So even if we write down the security policy to allow DNS traffic, so next generation firewall means what? First, of course, they will look at the layer 3 header, layer 4 header. So here, even if like the destination port is 53, so not 100% like verified that yes, it's genuinely a DNS traffic. No, even what they will do, they will open this application data and use the application signature database to identify whether it's genuinely DNS or not. So next generation firewall, they have complete understanding of applications, commonly used applications, even like built-in or maybe a software built for this IPS, intrusion preventive system, as a vulnerability protection mechanism here, and cloud delivered threat intelligence, to prevent from zero-day attack, unknown attacks. In fact, HTTPS inspection, another good feature. So what if like a malicious code or malware or like any bot or virus is inside encrypted data? Because nowadays most of the applications are HTTPS based. So HTTPS based means what? This one, the data is encrypted. So now you understand the problem. The problem is, if here there is a firewall, a computer here on the LAN segment, internet here, right? No, let's say I have used IPS profile or vulnerability protection, anti-spyware, antivirus, like advanced malware protection, everything is in place. But what if the communication is secure, SSL tunnel? I mean, like if this client is allowed to build secure tunnel, end-to-end SSL tunnel, secure socket layer. So even this antivirus or IPS or any other like threat prevention mechanism cannot prevent from like spywares, malwares, adwares, or keylogger or any P2P applications. Why? Because if end-to-end encryption is there, that means only layer 3 and 4 header will be in plain text. What about this data? Encrypted, right? Encrypted. And if the firewall doesn't have decryption key, It means if the content, the data cannot be decrypted by the firewall, so there is no point of doing examination. I mean, like, there's no point of checking for any known or unknown virus threat or like any malicious code inside it. At first place, there should be a decryption key, right? So in order to do like decryption and all that, most of the firewalls, they do provide SSL decryption or HTTPS inspection. At this point of time, just very high level overview of it, you can understand that is HTTPS inspection means at first place client or user is not allowed to negotiate tunnel end to end. No end to end encryption. It means two independent and separate tunnels will be negotiated. One tunnel between client and the firewall and another tunnel between firewall and the destination server. In this way, this firewall will have the decryption key, right? Decryption key. It means firewall will first decrypt the data and then like threat prevention policy or like IPS or some other like threat prevention mechanism will be applied then. Next generation firewalls, they do have like SSL decryption or HTTPS inspection like policy, and by using that, even encrypted content can be examined, can be checked for any threat, right? So it's another good feature offered by most next generation firewall, because in traditional firewall, even it was one of the technique like tactics used to bypass the firewall. Even there can be another tactic, that is tunneling inside SSH, secure shell, and very easily this can be done. Even like for example, let's say here there is a firewall and I have allowed like SSH and some other protocols because it's also required by like network or some other engineers. So let's say I have allowed SSH protocol, only SSH, right? But a user, what a user can do, a user can like first open or negotiate a SSH tunnel with any SSH server, right? By using putty, can like initiate a connection to like a standard port 22, and then using like this process setting from the browser, the traffic can be tunneled. I mean, like the traffic originated from the browser can be tunneled inside this SSH tunnel. It's known as SSH tunneling. And in putty, like there is option to tunnel the traffic, in fact. So you can make use of that. It means if SSH is allowed, so even you are free to use any application, no matter whether application is allowed by the firewall security policy or not. Even if the firewall security policy doesn't allow like Facebook or any social networking application or URLs, still this internal user can use like all the social networking and Facebook, right? It's known as SSH tunneling. So it's different from the SSL tunneling. So there are different ways to bypass the firewall, but most of the next generation firewall, they do have like some or other feature for like decryption. Anti-spam is there, email security, anti-bot, antivirus, and DLP like data loss prevention for the data filtering. So it just prevents leakage of any sensitive data, right? So sensitive data leakage can be prevented with this DLP feature. So it's another good feature of next generation firewall. Now the point here, like what we also need to discuss in this section, let me go back to the previous slide here. So application layer firewall, also known as like next generation firewall. And now we have understood that next generation firewalls means like complete threat prevention, vulnerability protection, anti-spyware, email security, anti-bot. Apart from like providing all the features of traditional or legacy firewalls like the VPN and of course port and address-based security policy, uh, routing and some other features. Apart from that, providing some advanced like threat prevention feature. So now here the important point what I want to discuss here is, what about then like web application firewalls or layer 7 firewalls, because they are also like layer 7 firewall, web application firewall, and of course there is next generation firewall, legacy or traditional firewall. The so up to this point, like we have understood that legacy firewalls means like no application aware inspections, no content inspection, no threat prevention at all. Evasive tactics can be easily used to bypass the firewall, right? uh, because they can be like port hopping, protocol hopping, or tunneling inside SSL, tunneling inside SSH. Next generation firewall means like there is like HTTPS inspection, even like IPS, like vulnerability protection, antivirus, anti-bot, DLP, anti-spam, right? Means next generation firewall means they operate up to layer 7 of OSI model. So the point here is like, then what is WAF then? Web application firewall. Because they are also known as layer 7 firewalls. So how WAF is different from next generation firewall? If I mean like the very like basic question, very basic question, and must be coming up in your mind, like if I have next generation firewall in my environment, do I still need to have a WAF, web application firewall? And if yes, then why? Because next generation firewall means again like operates up to layer 7, WAF like layer 7 firewall. So why do I need to have WAF then, like next generation firewall? Because WAF, like of course WAF is like a web application firewall, like a layer 7 firewall. Uh, it is mainly used to protect web applications from like cross site scripting attack, or like SQL code injection attack, or any injection attack, in fact, not only parameter tampering. Of course, here also there is a bot defense, like here also a data guard feature, which is similar to like DLP, right? Uh, some standard for payment card in industry. So WAF, up to certain extent, in fact, WAF and next generation firewall, they both have like similarities and differences, of course. Similarity, like in web application firewall, if there is data guard or anti-bot, or like vulnerability protection, so next generation firewall also. For example, in Palo Alto firewall, there is vulnerability protection profile, right? So with the help of this vulnerability protection profile, we can mitigate like these attacks like SQL code injection, cross site, scripting attack, and the other scripting attack, in fact, right? Even in checkpoint also, checkpoint firewall, there is IPS intrusion prevention system. So if we have enabled IPS profile, so even this SQL code injection attack or any other vulnerability exploitation cannot be used, will not be allowed to be used, right? So DLP sort of thing, like again we have in Palo Alto, Checkpoint, and most of the next generation firewall, they do have like some data leakage mechanism, in fact, to prevent data leakage or data filtering. So again, like the question remains there, like the difference between WAF, like a dedicated web application firewall, a layer 7 firewall, and a next generation firewall. So let me like bring out some differences here. Like one of the popular web application firewall is F5 ASM, Application Security Manager. So at first point, this web application firewall, F5 WAF, it means a full proxy architecture. That is two independent connections, not only for HTTPS, for any traffic, two independent connections, layer 4 connections are created because WAF are the is a like a reverse proxy device. It means connection is terminated to the device. Whereas like gateway or any other network device means sits in middle of communication stream, but not actually the terminating point of the connection. Here, like even if TCP, there is a TCP 3 handshake, then the TCP 3 handshake is done with the web application firewall, not with the actual destination, a real destination. No, right? It means full proxy architecture. Client first talks to this web application firewall, then web application firewall will talk to the backend server. Full proxy architecture. Full proxy architecture in web application firewall. So the advantage of full proxy architecture is what? Attack signatures, attack signatures can be used with both request and reply packet, right? Request packet and as well as reply packet, request packet and reply packet. So we can use attack signature with both request and reply packet. And this web application firewall, which is of course like a dedicated web application firewall, a layer 7 firewall, especially designed for the same purpose, like to protecting the web application. And web application means like of course consist of web server itself, application server and database server like SQL or MySQL database server sort of thing. So in web application firewall, in fact, without involving application development team, we can build and create a very tightened security policy, right? That is never possible with any next generation firewall. For example, we can like control individual entities, I mean like of HTTP application, I mean like uh, what file types of web applications should be allowed, right? What meta characters, parameters, even parameter length, values, HTTP method even. Usually we use like HTTP get or post message, right? Or head. Other HTTP methods like delete, put, and some other methods, they are very dangerous. They should not be allowed. So with the web application firewall, of course, like it has like a vulnerability protection mechanism, but not only vulnerability protection. In fact, with the web application firewall, we can do more than what the next generation firewall can do. For example, with web application firewall, at first place, full proxy architecture, attack signatures can be associated with both request and reply packet. Entities, what entities should be allowed, what entities should not be allowed is controlled. Whether HTTP request is as per the like RFC compliance or not, right? What HTTP methods should be allowed. Static protecting static and dynamic parameters so that like intruder or attacker should not be able to like modify parameter, or that is known as parameter tampering. No forceful browsing here. It means complete OWASP top 10 protection. And what is OWASP top 10? Open Web Application Security Project. Top 10 web vulnerabilities, right? Top 10 web weaknesses. A report like published in every 3 or 4 years, like after doing a lot of research work about top 10 web vulnerabilities. So WAF is like can protect from OWASP top 10, full proxy architecture, attack signatures, like vulnerability protection is there, of course, layer 7 distributed denial of service attack, like anti-ward, of course, even like IP rotation is also there. So, of course, next generation firewall, they can do they can provide vulnerability protection or even IPS sort of thing, but we cannot replace WAF with a next generation firewall. Is purposefully built web application firewall, yes, operate up to layer 7 similarities, even vulnerability protection, even like with the next generation firewall, like with the checkpoint firewall, Palo Alto firewall, we can do protection from the SQL code injection attack, right? Let me show you. Let me show you a very quick demonstration. So here, like I have F5 web application firewall, and if you see here, uh, application security, and let me, of course, it's not very relevant, like so. Just I'm showing you like what different options we have here in web application firewall. So don't worry, is something which is not required to understand checkpoint firewall, but from interview perspective point of view, at least you should know like some of the difference like between WAF and the next generation firewall is very common question nowadays, like difference between, because next generation firewall, of course, like they do provide a lot of security features what web application firewall provides. So that is why it's one of the common most question nowadays. So here, like if you look at the web application firewall here, so like HTTP protocol compliance, like what should be allowed, what should not be allowed here. Apart from that, like different attack signatures and evasive techniques detected. So like the next one is allowed file types, URLs, parameters, session, cookie tampering, even content profile, cross-site scripting, IP address geolocation, what HTTP header should be allowed, what method should be treated as illegal method, and redirection, domain redirection protection, bot protection, data guard, which is similar to DLP, right? Antivirus, server technologies, and even if you look at different options here. So in web application firewall, even we can specify what all file types should be allowed or disallowed in web application. I mean JPG, PNG, or PHP, ASP, what all file types should be allowed, what all URLs should be allowed and disallowed, while characters, even parameters, values, length, attack signatures, headers, even like HTTP, what HTTP methods should be allowed. So we can specify like individual component of HTTP, in fact, right? Even if HTTP header is not as per the RFC compliance, then HTTP request is rejected because it will trigger a violation. I mean, like if here is a web application firewall and a request, HTTP request arrives here. HTTP request, it means IP, TCP, and HTTP here, right? So it's not about identifying the HTTP application. Let's say identified that the application itself by any like firewall, next generation firewall or any firewall in front of this web application firewall, identified that application is HTTP. Now here, next is what? This web application firewall will check whether this HTTP header is as per the RFC compliance or not, whether each line is like ending with carriage return or not, right? If HTTP header itself is not RFC compliant, then a violation is triggered. Illegal HTTP header violation is triggered, and based on the policy, requests will be either like dropped or will be allowed, only logged or alarmed. That depends like what kind of security policy we have created here. But in web application firewall, even like if the file type, let's say PHP file type is not allowed, So you cannot use PHP. HTTP delete method is not allowed. HTTP delete method, again the HTTP method is mentioned inside HTTP header itself, right? You must have seen like get, the commonly used method get, and then the slash, and then version. So get is what? HTTP method. So what HTTP method should be allowed, what HTTP method should not be allowed, we can specify it here. Parameters, URLs, everything. And most important point here, most important point is almost done automatically. I mean, like without involving web development team. So if you are the security engineer, right? So you don't need to involve your web or server team. In fact, web application team, right? Because like there are different ways here. Automatic learning is one of the way. Like first, like this device will learn all the used file type, URLs, and everything, and then we will just like create the policy and all that. So you understand like this web application firewall cannot be compared with the next generation firewall. Yes, like up to certain extent, like some of the features are common features, but not all. But not all, because even if I show you like this Palo Alto firewall, so in Palo Alto firewall also there is a vulnerability protection profile, 313 total, like 11,142 vulnerability protections, like different common vulnerability exposures CVE in 2005, and the number is 12772. So when this Palo Alto firewall will provide protection from like SQL code injection attack, cross-site scripting attack, right? Very similar to like this web application firewall. And even if I show you like, and let me give you a very quick demonstration. And so just to make this point very much clear to you. So here like I have a checkpoint firewall. Later on, like we will talk about like checkpoint firewall technologies, and how to deploy that configuration, everything. So rest assured, not to worry with it. It's just a very quick demonstration. So I don't want to get into detail of it, because it's something like that would be discussed later on. So at this point of time, just I want to show you like how like this web application firewall is different from the next generation firewall. So here like the checkpoint firewall, of course, the next generation firewall, and in DMZ there is a web application, and here like on Linux based PHP, and the database here is MySQL, complete database. Already here like on gateway there is a static NAT policy created here, and I'm sitting here on the external network side, right? I want to access this web server in the DMZ with this netted IP. I mean like the external interface IP address. And this web server has too many vulnerabilities just for the testing purpose, right? Vulnerabilities. So let me show you. So here like I have a checkpoint firewall configured here, and there is a NAT policy here. NAT policy to check the NAT policy to access the server. So now here and there is a security policy here. Security policy is to like allow any traffic coming from any source to this DMZ web server. So it's very quick, and as such there is no IPS in fact enabled. IPS profile is not enabled here. So here like I have access to DMZ web server with this external IP address, and now a SQL code injection attack. It's a code here, SQL code, and without any valid username and password, with the SQL code, I have been allowed to log in. And even if I go to your control panel, then I can check the, like, I can find the detail of all the users like of like SQL database. I mean, like the username, credit card number, email address, everything. It's a kind of SQL code injection attack. So let me explain you one more time here. So here, like, there is a checkpoint firewall. It has security policy. Security policy allows incoming HTTP traffic to this DMZ web server, and this web server has too many vulnerabilities, right? And I have accessed the web server, DMZ web server, with this IP address 192.168.0.111, because here, like, there is a static NAT policy already created. So yes, I was allowed to access the web server, but I was also allowed to do some kind of like attack, SQL code injection attack, and with the help of SQL code injection attack, in fact, I was able to retrieve user database, right? So can we prevent this SQL code injection attack from checkpoint firewall? Answer is yes. At least this SQL code injection attack, yes. What about other attacks like the, let me show you another, let's say it's a username here with the student one, and the attack here is parameter tampering attack. Now I'm going to replace student one with the wildcard asterisk. It's another attack, and it's a parameter tampering, right? What about any scripting attack? Like, let's say, let me write down a script here. So of course, like as there will not be any output of this, but at least allowed. So can we prevent SQL code injection attack, parameter tampering, cross-site scripting, or like OWASP top 10 attacks by using this checkpoint firewall or Palo Alto or any next generation firewall? Some of the attacks, yes, but not all, right? But with the web application firewall, yes, we can prevent from parameter tampering, SQL code, cross-site scripting, or even like cookie tampering, right? But not with the next generation firewall. And if I show you, let me enable now this profile IPS, intrusion preventive system, enable, and I need to push the policy. Not to worry with all this, like how I'm like creating a policy or was like policy installation and all that. It's just a demonstration only. Need not to worry about it. I'll explain everything from the scratch, from the very beginning. So first, like, we'll understand checkpoint firewall technology, its deployment, initial configuration, then security policy, NAT policy. So we will start from the scratch, not to worry with that. Just I'm showing you like how this web application firewall is different from next generation firewall. So of course, like we are not going to replace like next generation firewall with web application, or web application firewall with next generation firewall, right? So policy installation succeeded on security gateway, and as of today, there is no log of this threat prevention. Now launch SQL code injection attack one more time now. This site cannot be reached, right? And is there any log file? So refresh. Here we go. Source IP address DMZ web server and here even the resource is there and the protection name SQL injection scanning attempt. So now there is IPS intrusion preventive system. So prevention from vulnerability exploitation. So vulnerability protection. So it's possible. What about other attacks? So for example, your control plane, and let's say again, if I say here, so now no protection from parameter tampering. What about running a script? So protection from, of course, SQL code injection attack. So up to certain extent, yes, we can do a lot with next generation firewalls, because they are of course operating up to layer 7 of OSI model, but we cannot do everything with the next generation firewall as we do with the web application firewall, purposefully built layer 7 firewall or web application firewall to provide complete protection from attacks and OWASP top 10 and you know like uh, what entities should be allowed, what entities should not be allowed. I mean, like the file type, parameters, meta character, parameter values, length, everything.